Finite differences and interpolation. In the previous videos, we solved the examples in which the interpolation had equal intervals, that is, the values of x were equally spaced. Now, today we'll solve the examples in which the interpolation is with unequal intervals, that is, the values of x are unequally spaced. To solve these type of examples, we have two formulas. One is the Lagrange's interpolation formula and the second one is Newton's interpolation formula with the divided differences. Here we'll see the examples based on the Lagrange's interpolation formula. The formula is like this: f of x is equal to x minus x1 into x minus x2 up to x minus xn upon x naught minus x1 into x naught minus x2 up to x naught minus xn into f of x naught. Here you will see one thing, that as the first term is f of x naught, so all the terms that are in the denominator start with x naught, and in the numerator you won't find the term x naught anywhere. Now if we talk about f of x1, then again you will see the same thing. In the denominator the values start with x1, and in the numerator will not see x1. Then if we have f of x2, it will be also same, like it will be x2 minus x0, x2 minus x1 and so on, and in the numerator it will be x minus x0, x minus x1, but you won't see the term x minus x2. So this is the formula, Lagrange's interpolation formula. You'll have to remember this formula, and this was one trick by which you can remember the formula. Now let's solve this question. Here, as you can see, all the values of x are unequally spaced. That is, there is no equal difference between the values of x. Using Lagrange's interpolation formula, find y when x is equal to 10. So we have y of x is equal to, first term we'll take it as f of x naught, or we can even say y naught. So as we are taking x naught, so in the denominator all these terms will start from x naught, that is x0 minus x1. You can label it like this, that this is your x0, x1, x2 and x3. Then x0 minus x2, x0 minus x3, here it will be y naught, and in the numerator it will be x minus x1, then x minus x2, x minus x3. But nowhere you will take the term x naught in the numerator. Now same way it will be for y1, which is here in the denominator we'll take x1 minus x0, x1 minus x2, x1 minus x3. Multiply it, that is the whole term, with y1. In the numerator it will be x minus x0, then directly x minus x2 and then x minus x3. Now if you will see in the second term, I have made a writing mistake. It's very much possible that you might think the formula correctly but you won't write it correctly, and it will lead to some consequences. I'll explain it later on. Now here our next term is related to y2. So in the denominator all the terms will start with x2, and in the numerator you will not find x2 anywhere. In the numerator all the values start with x. So it will be x minus x0, x minus x1, x minus x3 divided by x2 minus x0, x2 minus x1, x2 minus x3 whole multiplied by y2. And the last term will be y3, So here it will be x3 minus x0, x3 minus x1, x3 minus x2. And in the numerator, it will be x minus x0, x minus x1, x minus x2. Always have a habit that once you have written this formula, just check it, because it is possible that you might have thought it correctly but you won't write it correctly. Now, as in the second term I told that I have not written it correctly, I have written it as x minus x1 and x minus x2, which should actually be x minus x2 into x minus x3. So if I write it wrongly, then I'll keep the values of x1 and x2 in it in place of x2 and x3. So ultimately, I'll just get a wrong answer. That's why I'm saying that have a habit of rechecking your formula. Now we'll just place all of the values. Here our x is equal to 10, x0 is equal to 5, x1 is equal to 6, x2 is equal to 9, and x3 is equal to 11. Once you have written the formula correctly, it's very much easy to place all of these values. I have even shown you the trick how you can remember this formula. The values of y naught are 12, then y1 is 13, y2 is 14, and y3 is 16. It will be 9 minus 5 into 9 minus 6 into 9 minus 11 and whole multiplied by 14. Then this will be 10 minus 5 into 10 minus 6 into 10 minus 9 upon 11 minus 5, 11 minus 6, 11 minus 9 whole multiplied by 16. On solving the first term, we get it as 2. So it will be equal to 2 plus the second term comes out to be minus 4.3333 plus third term is 11.6666 plus 5.3333, which is equal to 14.6666. That is 14.667. So this is the value of y of 10. That is the value of y when x is equal to 10. Now let's see one more example. Using the Lagrange's interpolation formula, find a second degree polynomial passing through the points 0, 0, 1, 1 and 2, 20. So here the question has not been given to us in a tabular form, but it's very much simple. You'll just need the values of x0, x1 and x2. First values are the values of x and the second values in the bracket are the values of y. So x0 is 0, x1 is 1, x2 is 2, then y0 is 0, y1 is 1 and y2 is 20. Again we'll write the formula and then we'll input the values in our formula. So y will be equal to, as the first term is multiplied by y naught, you can either start from the numerator or from the denominator. I have already shown you the trick. As the first term is multiplied by y naught, so in the denominator we'll have x naught, that is x naught minus x1 into x naught minus x2, and in the numerator we'll have x minus x1 into x minus x2. For the second term, it's multiplied by y1, so in the denominator it will be x1 minus x0 into x1 minus x2, and in the numerator it will be x minus x0 into x minus x2 plus third term is multiplied by y2. So in the denominator it will start from x2, which is x2 minus x0 into x2 minus x1, and in the numerator it will be x minus x0 into x minus x1. If you find it convenient by using some other trick, then you can remember the formula in that way. Now we'll just input the values. So here we'll get an equation in the form of x. Y is equal to x minus 1 into x minus 2 divided by 0 minus 1 into 0 minus 2, and as our y naught is 0, so this whole term will be multiplied by 0, plus x minus 0 into x minus 2 divided by 1 minus 0 into 1 minus 2. y1 is equal to 1, so we'll multiply it with 1. Then x minus 0 into x minus 1 upon 2 minus 0 into 2 minus 1, and whole term multiplied with 20. So our first term will be equal to 0. Then the second term will be minus x into x minus 2, because in the denominator we have 1 minus 0 and 1 minus 2. So 1 minus 2 is minus 1. So it will be minus x into x minus 2 plus 10x into x minus 1. So it comes out to be 9x square minus 8x. This is how you can solve the examples based on the Lagrange's interpolation formula. You'll find my notes on my website, and the link to it is in the description. Thank you.